Hi, in this video I'm going to talk about the factor theorem. What actually is the factor theorem? Well, I've written it down here for you and I'm going to show you, okay? This is really what the factor theorem is now. I've just simplified it a little bit, okay? So for a polynomial function f of x, okay, if f of a equals 0, this implies, and it's implied by x minus a as a factor. What does that actually mean? What does that mean? Well, I'll show you a simple example using GCSE maths, okay? So it might be that you've got a quadratic like this, x squared plus 5x plus 6 equals 0, for example. And you can factorise that, can't you? Okay, you get x plus 2, x plus 3. What do you then do to solve it? You write down the two possible answers using the factorised expression here, okay? So from this bracket we've got x is negative 2, and from this bracket you got x is negative 3, okay? Well, let's just go back to this, okay? We're looking at x minus a being a factor. Well, in this case, x plus 2 is a factor. And reading from right to left, this implies that f of a is 0. In other words, that implies that negative 2, f of negative 2 is 0. And it is. If you substitute in, x is negative 2, you're going to get 4 subtract 10 plus 6 equals 0. Okay. Similarly, this here again, x minus a is a factor, f of a is 0. This here is a factor, okay, and so working from right to left, that implies that x equals negative 3 equals 0 as well, okay. What about from left to right, okay? Well, let me just show you. If I started off with another example, call it example 1, example 2. If I told you that in a quadratic equation you had two different roots and the roots were 1 or negative 4, would you be able to write down a quadratic equation for me? Of course you would, okay? If I tell you one of the roots is 1, then x subtract 1 has got to be a factor, hasn't it? Okay. If I told you another root was negative 4, then x plus 4 has got to be another factor, okay? And so a quadratic equation you could write down is that, okay? Actually, it could be any multiple of that. It could be 2 times all of that, 3 times all of that, but that's the simplest one to write down, isn't it? And that's what this bit here is saying, okay? It's saying that if f of a equals 0, this implies that x minus a is a factor, okay? So the factor theorem is basically these two examples combined, okay? It's, if you know two of the roots, you can write a equation in its factorised form like this. X equals 1 as a root implies that this is a factor. X is negative 4 as a root implies that that's a factor, okay? Or the other way round, you could say that if you know the two factors, you can write down what the two roots are. And that's really what this line is saying. It's just a much more simplified way of saying it, okay? I'll say it again. If f of a, where a is a number, is equal to 0, this implies x minus a is a factor, and the other way round. The double-headed implication arrow means it also implies that if x minus a is a factor, then f of a equals 0. What about the bottom line, okay? Well, let me just adjust this example slightly as I look for my board rubber, okay? Let's just go back to this one, okay? Suppose I give you two factors, x equals 1, okay? Sorry, two roots, x equals 1, so that's a factor, and x is equal to, let's just say, negative 3 over 4, okay? Would you be able to write down what the other factor is? Of course you would, okay? It would be 4x plus 3 equals 0. And how do you do that so quickly? What you do is basically you say, well, if x equals negative 3 over 4, bring the 4 across the other side, 4x equals negative 3, put the negative 3 into that side, 4x plus 3 equals 0. Okay, that's where you get your other factor, okay? And that's what this is saying, you see. If you've got b over a, okay, in other words, we're talking about fractions rather than integers here, okay? If you've got f of b of a equals 0, this implies that ax minus b is a factor, okay? In this case, that is the b over a, okay? Negative 3 over 4, that implies that 4x plus 3 is a factor. And the other way around, okay? If you know that that is a factor, then this here must be a root, f of b over a equals 0. So in other words, if you know that 4x plus 3 is a factor, you can say that that is a root. Let me just give you another example on that. So without me writing out the top line, let's just give you something completely different. So x minus 5 and then 2x plus 1 equals 0. You can write down straight away, see that x equals 5 is a root, or then from this bracket, x equals negative a half is a root. Okay, and you can go backwards. Okay, if I told you that those were the two roots, you'd be able to deduce that those are the two factors. Okay, so that's really what the factor theorem is all about. Okay, I thought I'd introduce it using quadratics because that's something you should be very familiar with. Okay, I'm hoping you found it useful. Okay, and coming up are some examples of putting the factor theorem into practice.